I welcome you to this online tutorial on formula stoichiometry and model concept. We are going to continue from where we stopped. I had introduced this section and I had left an activity. I had left an activity behind, which was on calculating RFM, determining number of particles, calculating moles, and determining weights. So we are going to go through some of those questions in this tutorial. I will remind you that if at all you have any questions, feel free to contact me on these contacts that you can see on your screen. That is, if at all you have any question regarding formula stoichiometry and model concept. Now, we had covered all these things. We had covered all this information. We had gone through this mind map. And I had left this activity behind. So today I want to go through the responses to those items that I left behind. They were around 4 questions. So question 1 was on calculating the relative formula masses of the compounds which were given. So calculate the relative formula masses of the following compounds. We are given that the relative atomic mass of magnesium was 24, that of hydrogen was 1, that of carbon was 12, that of oxygen was 16, and that of iron was 56, and that of sodium was 23. Now, this information on relative atomic masses is always given. It may not be aligned with the item, but you can check at the front page of the given question paper. You'll always find this information on relative atomic masses always given. So item 1, Roman 1, you are meant to calculate the relative formula mass of magnesium hydrogen carbonate. Now, to calculate RFM of magnesium hydrogen carbonate, you need to know how magnesium hydrogen carbonate looks like, as in what is its formula. So to take you through the formula of magnesium hydrogen carbonate, so within magnesium hydrogen carbonate, we have a metal magnesium, and we have a metal magnesium and a radical hydrogen carbonate. So this is information that we covered some time back. So magnesium hydrogen carbonate has a metal magnesium, which is Mg. Then it also has a radical hydrogen carbonate, which is H, C, O, which is oxygen, and the 3. So this is the formula of the radical of hydrogen carbonate. Magnesium has a valence of 2, and hydrogen carbonate has a valence of 1. So if I exchange these valences, 1 will come here down, and 2 will also come here down. Therefore, the formula of magnesium hydrogen carbonate is given by, so we have Mg, then we have H, followed by C, O, 3. But we exchange the valences. Therefore, I'll put a bracket here, and I'll also put another bracket here. Then this 2 from magnesium will be here down. So I am including these brackets because this 2 is on the entire radical of hydrogen carbonate. So you have to include the brackets to show that it is on this entire radical of hydrogen carbonate. Then 1 comes here where we have magnesium. There is a silent 1 here, but I can ignore it. Therefore, magnesium hydrogen carbonate looks like this. Hope you've noticed how it is formulated. I can now take it off. Having noticed how magnesium hydrogen carbonate is formulated, now we can look at how its RFM is determined. So RFM of magnesium hydrogen carbonate, therefore, is equal to, so we have MgHCO3 and 3CO3 and 2 here. This 2 comes from magnesium. So you need to know how to formulate the formula of a given compound. Therefore, RFM is 24, Mg is 24. Recall that RFM is the sum of the relative atomic masses of the different atoms that make up the given compound. Therefore, Mg is 24 from this information in the bracket. Then there is a bracket here from the formulation of magnesium hydrogen carbonate. Then after the bracket, we have hydrogen, which is 1. We have carbon, and carbon is 12. Then plus, we have oxygen, and there are 3 atoms of oxygen. Therefore, we shall have, and each atom is 16. We shall have 16 times 3. We close the bracket, then times 2. This 2 arises from this 2, which came from the valence of magnesium. Therefore, summing all this information up, we obtain 146 as the RFM of magnesium hydrogen carbonate. Next, we have iron 3 oxide. Now, for iron 3 oxide, we have iron 3 oxide. There is iron which is Fe, that is the formula, the symbol of element iron, Fe. Then there is also oxide, which is the radical oxide. Its formula is O. So iron 3, that is iron with a valence of 3. Oxide has a valence of 2. So exchanging, we have a 2 coming here and a 3 going here down. Therefore, the formula of iron 3 oxide is Fe. Then we have a 2 that comes from oxygen. Then we also have O and a 3 that comes from iron. Therefore, iron 3 oxide is a compound that has this symbolic representation. As a result, RFM, I think I need to take this off. Hope you've seen how iron 3 oxide is formulated. As a result, RFM of iron 3 oxide is equal to, hope my screen is visible. RFM of iron 3 oxide is equal to 56. Fe is 56, but there are 2 of them, 56 times 2. Then plus oxygen, which is, oxygen is equal to 16, and there are 3 of them, that is 16 times 3. And summing all this information up, we obtain 160 as the RFM of iron 3 oxide. Next, you have sodium carbonate 10 water. Sodium carbonate 10 water, this is how it looks like. So it has, let me start with the sodium carbonate. Sodium carbonate, to formulate it, it is made up of a metal, sodium, which is Na. Then it also has carbonate. Carbonate is a radical given by CO3. This is the symbolic representation of carbonate, CO3. Then sodium has a valence of 1, carbonate has a valence of 2. So exchanging, we shall have the 2 come here down, and also the 1 come here on the carbonate. Therefore, sodium carbonate is Na. Then we have these 2 down, the 2 which comes from carbonate, then followed by C, O, and a 3 on oxygen. So this 1 from sodium comes on this entire radical of carbonate, but one doesn't change anything. So we can just simply ignore that. Then DC2 comes from the valence of carbonate. Therefore, sodium carbonate, this is how sodium carbonate looks like. Then followed by 10. So 10 water, we shall put a dot. Then we shall write our 10, 1, 0. This is our 10. Water, and water is H2O. H2, H2O. So this is sodium carbonate, 10 water. That is how it looks like. Hope you've seen how it is formulated. Now I can put this off. So I erase it. Then we see how to calculate the RFM of sodium carbonate 10 water. So for sodium carbonate 10 water, we shall have RFM of sodium carbonate 10 water is equal to, so we have sodium with the 2 here down, and each sodium is equal to, each atom of sodium is equal to 23. Therefore, that is 23. We have 23 times 2 plus C, carbon, C is 12 plus 12, then plus O is 16, and there are 3 of them. So 16 times 3, then plus, we have 10 here, so plus 10. We open our brackets. This is 10, since this 10 is multiplying throughout H2O, therefore we need to write 10 and open brackets. This 10 is multiplying throughout. So we have H, and there are 2 of them, and each H is 1. So we have 1 times 2, then plus O 16, then close brackets. Summing all this up, we obtain 286 as the RFM of sodium carbonate 10 water. So basically, this is item 1 on calculating relative formula masses of the different compounds. Therefore, in brief, we have to take note of the following. This information is important when calculating RFM of different compounds. So when calculating RFM of different compounds, as a learner, as a chemistry student, you have to know how to know how to write correct formulae of compounds. So you need knowledge on how to identify, on how to write correct symbols of elements that make up a particular compound. So that information is necessary. Writing correct formulae of compounds, and to write a correct formulae of compounds, you need a lot of things. You need to know the symbolic representation of elements that make up the periodic table, or elements that make up a particular compound. Like here, we wanted to calculate RFM of magnesium hydrogen carbonate. You must be knowing how magnesium hydrogen carbonate looks like. And to know how magnesium hydrogen carbonate looks like, you must be knowing the symbolic representations of these things that make up magnesium hydrogen carbonate. You must be knowing how magnesium looks like, how also the radical of hydrogen carbonate looks like. So to calculate RFM, the first thing which you must take note of is writing correct formulae of compounds. Next, you have to interpret brackets within the compound correctly. Like here, I had to introduce brackets when feeding in relative atomic mass of hydrogen, and also when feeding in relative atomic mass of carbon, and also that of oxygen. I opened the bracket here, and I also closed a bracket here. So at times you will encounter items where you will be given the formula of a compound. So given formula of a compound, you have to interpret that formula correctly so that you do not mess up with the item. Then you also have to substitute correct relative atomic masses of the elements that make up a given compound. These RAMs, the relative, I am acronyming them as RAMs, the relative atomic masses of the different elements that make up a compound. That information is always given. It may not be attached directly to the item, but you have to look at the preamble of the question paper. That is, you look at the front page of the question paper. That information will always be given. So in summary, that is item 1, and allow me first pause this here. Then I look at item 2.